Alright, so we're going to go ahead and do area of a kite. So a kite, pretty basic shape right here. The area of a kite will be determined by doing your diagonals multiplied divided by 2. Okay, and that's pretty much it on what you're going to be doing on them. So if you could calculate your diagonals, you're going to be done. In this problem right here, there's a lot of information, but again, all you need is your diagonals. So just by looking at it, I could look at this kite here, and your kite, if you imagine it, if you fold it along one of the diagonals, it's going to be, right down the middle. So this is 4, this is 4, that's pretty clear, should be pretty obvious. So I know that my diagonal here, this vertical one, the diagonal is 8. I know that this diagonal over here, the horizontal one, is 13. So according to my formula, all I have to do is just multiply them. 8 times 13 is divided by 2. So 8 times 13, and that divided by 2. So the area of this kite right here is 52. It's that easy. Okay. Let's look at this next problem right here. There'll be times when they give you a kite and they give you numbers on the outside, but with those lines. And all I want to say is imagine where they go in the kite. This 10, for example. This 10, if I was to, just move it parallel this way, boom, it's that diagonal right there. Likewise, this 4, if I just move it slightly up, it's that diagonal right there. So I know that D1 is 10, I know that D2 is 4, so it's just 10 times 4 divided by 2. 10 times 4 is 40, divided by 2 is 20. So the area is 20. That's it. So again, if you know your diagonals, you're pretty much set. Let's look at another one where you don't know a diagonal. All right. So on this problem right here in the bottom, they're telling us that this is 10 and this is 15. Maybe as you saw on the first picture, what's so special about a kite is that these two sides are going to be the same and these two sides are going to be the same. And it's going to be obvious which ones are the same, because sometimes your pictures are flipped. As you could see in this picture here, these two are the same, these two are the same. Now, your diagonals, when they intersect in a kite, they form a 90-degree angle. And all we're going to do is we're going to focus on this part right here, this triangle right here, to find this red part. So I have a right triangle where I know this is 10 and I know this is 6. Pythagorean theorem, yes. So if I do Pythagorean theorem, I'm subtracting. If you don't remember why and how I get to that part right away, go ahead and look at the video on Pythagorean theorem. So 10 squared minus 6 squared, and that's 8. So I know this is 8. So if that's 8, I would expect this to be 8 right away, because again, imagine folding it, these two will be the same. So my diagonal, one of them, I'm just going to write it over here, one of my diagonals is 16. On my other diagonal, you can't say that this is 6, it's obvious, they're different sizes. But if we just focus now on this triangle right here, now we know this is 8, we know this was 15, and we're looking for this bottom part. Once again, we're going to do Pythagorean theorem. Okay, notice how we use Pythagorean theorem a lot, so it is very important that you know when to use it and how to use it. So 15 squared minus 8 squared. So this piece right here ends up being 12.7. And so my second diagonal, now that I know that this is 12.7, I'm just going to add them up. So 6 plus 12.7, that's 18.7. And now that I have enough information to, find the area, I just substitute. 16 times 18.7 divided by 2. 16 times 18.7 divided by 2. And so my area is 149.6. And that's it, guys. That's how you find the area of a kite. Okay. So if they give you the information, right away substitute and you're done. Substitute into the formula. If you're missing information, you're probably going to have to do Pythagorean theorem. All right, thanks.